So we can say that. Let me give you another example. We want now, this time, we want to write divisors of 7. What numbers are what are the numbers that 7 are divisible to them? 1 is for sure, as you said. 7 is divisible by 1, but another number is 7. That's all. You cannot find any other number in the positive integers, of course. We're talking in our domain is positive integers. So the only divisors are 1 and 7. So it has only 2 divisors. Because it has only 2 divisors, so 7 is a prime number. 7 is a prime number. Okay, let me give you one more example about divisor, and then we can switch to prime number and what is a composite number, what is a prime number. Okay, we want to write divisors of 10. Will you tell me?
Divisors of 10 is 10 itself, 20, 30, 40,
No. Divisors of 10, not multiples of 10.
Oh. Okay.
Divisors of 10 is 10 itself and 1. So 1, 10. Okay. What else?
2.
2 and 5 come with together. So 2 and 5 come together. 1 and 10 come together. As it is the case here, 1 and 6 come together. 2 and 3 come together because when 6 is divisible by 2, 6 is divisible by 3 also. And then these two come together. Okay, very good. Now we want to be focused on the numbers which has only 2 divisors, prime numbers. Let me write some of them. Prime numbers. Can you let me start writing them. For example, 2 is a prime number because it has only 2 divisors, 1 and 2. 1 is not a prime number because 1 has 1 divisor only. Another example is 3. 3 is a prime number. Okay, can you give me more examples of prime numbers?
The one that has 2 divisors?
Only 2 divisors, not more.
Right, but how do you find out that how many divisors they have?
Okay, by just searching the divisors. For example, let's examine some more. For example, here when we wanted to find the divisors of 10, we examined 2 and then we said yes, 10 is divisible by 2. So 2 is a divisor. When 2 comes, 5 comes also. As I told you, 2 and 5 come together. And 1 and 10 come together. So we understand that it has 4 divisors, which means it has divisors other than itself, other than 1 and itself. Because 1 and itself is only a divisor of a number. Whatever number it is, for example, assume 17 or 25. 1 and itself is only a divisor. It is always a divisor. Do you understand what I mean?
Not really.
Okay, so let me erase here and then work with divisors a bit more. Okay, here are another example. We want to know what are divisors of 25. Okay, so we check. Of course, 1 and 25 is always there. As I told you, 1 and 25 is also 1, and the number itself is always divisor, because 25 is divisible by 1 and 25 is divisible by 25, right? We want to search what other number are there, or is there any other number that 25 is divisible to? For example, we search by going through 5. Very good. 5. We can search by 2, then it's odd, it's not even, so it's not divisible by 2. And then we can check the 3, the sum of numbers is not divisible by 3. 4 is not divisible by 4, because when a number is not divisible by 2, it's not divisible by 4. And then we can go to 5 and more. Okay, more example. Divisors of 13. Divisors of 13. Please think and tell me.
Of course it's 1. One of them is 1.
1 and 13 definitely included.
I can't find out.
Okay, you cannot find any other thing. You cannot find any other thing because it has only 2 divisors. It has only 2 divisors. It has no other divisor. For example, if we think of 2, 13 is not divisible by 2. If we think of 3, 13 is not divisible by 3. 5, the same story. 7, the same story. Of course, we don't need to go until 13 because it is not divisible by 2, 3, 5, and 7. It is enough. It is enough here that we can say that it is a prime number. It has only 2 divisors, 1 and itself. Okay, so let me count some prime divisors for you. I'm sorry, let's count some prime numbers. The prime numbers are the numbers which has only 2 divisors. Here is the definition. Has 2 divisors only. One of them is 1, the other is itself. One is the 1 and the other one is itself. Okay. These are prime numbers. 2, 3, 5, 7, 11, 13, 17. These are prime numbers. We have infinite number of prime numbers. We have infinite number of prime numbers. Pay attention. We have 2 is the only prime number which is even. 2 is the only prime number which is even. All other even numbers are not prime. Can you tell me why?
Because they have more divisors or less? I mean more divisors or less?
They have more divisors. They have more divisors. Let me tell you an example like this. Are the following numbers prime? Are the following numbers prime? So, for example, 4 is one example. 6, 8, 9, 15. These are some examples. So we concentrate on each number here. It has It has 1 and 4 for divisors for sure. 1 and 4 are divisors of this. But it is divisible by 2 also. It is divisible by 2 also. So we have more. We have more than 2 divisors. So it is not a prime number. Okay, now 6. How many divisors does it have? Or does it have more than 2 divisors?
It has more than 2 divisors.
It has more than 2 divisors. For example, what other divisor does it have?
It has
What are divisors of 6?
divisors of 6 are 1, 2, 3, and 6.
1, 2, 3, and 6. Very good. So it has more than 2 divisors.
Yes.
The only numbers which are prime numbers which are only have divisors, the only divisors are 1 and themselves. So it has more divisors. It has 2 and 3 also. It has 2 also. So whatever even number that we can think of except 2 is not a prime number, because it is divisible by 1, it is divisible by 8, but it is also divisible by 2. So it's not a prime number. Now, what about 9?
9 is divisible by, 9 is a prime number.
9 is a prime number. Are you sure? Let's examine the numbers which are divisible.
1,
1,
3,
3, 1, 3, and 9, right?
3 and 9, yes.
1, 3, and 9.
That's not divisible.
So it is not a prime number. And what about 15?
15? Well, it's 5. It's 1, 5, 3, so it's not divisible.
It is not a prime number because it has more divisors than 2. So maybe I have gone a bit fast here. Let me write some examples to clarify the thing more. Let me clarify the subject more slowly. For example, write divisors of 12. Then decide if it is prime or not. Then decide if it is prime or not. Okay, what are divisors of 12?
1,
1,
1, 6.
6. Let me write 1 and 12, because 1 and 12 come together. 1 and 12. Very good. 6.
And 6 and 2. 6 and 2.
Very good. 6 and 2 come together. Excellent. What else?
But we already know it's not a prime number.
Very good. We already know it's not a prime number. It's not a prime number because it has more than 2 divisors. Very good. Let's complete the divisors.
Mm,
You need to divide one by one. For example, 12 divisible by 1, 12 divisible by 2, and then we can check the 3. If we can check if it is divisible by 3 or not. Right?
okay, so this is by 3.
It is divisible by 3, and therefore 3 and 4 come together. 3 and 4 come together, and nothing else. Nothing else. For example, 12 is not divisible by 5, or 12 is not divisible by 7, and nothing else. These are all divisors of 12, and as you said, because we have more than 2 divisors, 12 is not a, so 12 is not a prime number. Okay, very good. Let's go back to here. A number is called prime if its only factors are 1 and itself. Factor is another expression for divisor. We also call it factor. Factor or divisor is the same. Okay, for example, 7 is a prime number. The only factors of 7 are 1 and 7. Okay, now, a number is called composite if it has more than 2 factors. For example, 8 is a composite number because 1, 2, 4, and 8 are all factors of 8. So here we can say in our example, we can say 12 is a composite number. 12 is a composite number because it has more than 2 divisors. Okay, so we have prime number and composite numbers. Let me write the definition of composite number here. So composite number, what is the definition of composite number? Has more than 2 divisors, or has more than 2 factors. Okay, let's do some examples again. For example, number 30. We want to know if it is a prime number or it is a composite number. Can you tell me?
3 is divisible by 1 and 3.
1, 3, many other numbers, of course.
Yeah, a lot.
Many other numbers. So
It's a composite number.
it's a composite number. Very good. So a composite. So it's a composite number. Now, number 17.
Number 17 is 100% divisible by 1.
Very good. It is divisible by 1. It is divisible by 17, which is itself. What other numbers? Let's search for other numbers.
That's 17 times 2.
17, is it divisible by 2? We say no. 17, is it divisible by 3? No, because sum of digits is not divisible by 3. Is it divisible by 4? Of course not, because it hadn't been divisible by 2, it will not be divisible by 4. Divisibility by 5 again fails. That's all. That's all. Because if
That's a prime number.
So it's a prime number. I can say, I can check until 5 here, because if it has a factor greater than 5, the other factor will be less than 5. I don't know if you understood this my last sentence or not.
I didn't. Can you repeat?
Yeah. I checked the prime factors, I checked the factors until 5. For example, I said 17 is not divisible by 5. And I didn't check other numbers because I said if it had a factor greater than 5, it certainly will have a factor less than 5. Do you understand what I mean?
Oh, so if it has a factor more than 5, so if the factor is more than 5, it should have a factor less than 5, right?
Right.
Okay.
For example, 28. 28. It has a factor. When I search for factors, I come across 7. 7 is a factor. But 7 times 4 is 28. You know, when a factor is greater than some number, the other factor must be smaller. You know, it's like this. Of course, 28 is a composite number. 28 is a composite number. Let me give you some more. 100. Is it composite or prime?
Composite.
Composite. Very good. How do you say so quickly?
Because I think every number that is no, like every number that has, I think that's divisible by 5. Every number that has a zero, like 10, 20, 30 or stuff, and it has more. So that's how.
Very good, very good. Every number which has a 0 at the right, very good. It is divisible by 10, or it is divisible by both 2 and 5. Very good. So it has more divisors. Excellent. What about this one? 222. Is it composite or prime?
I think it's composite.
I think it is.
I think it is composite.
It is composite. How? How do you know? We check the numbers. We check the numbers. If we check the numbers or divisors, is it divisible by 2? We say yes. It is divisible by 2. How? How can we say it is divisible by 2?
Because the unit digit is divisible
The
by
unit
2?
digit is divisible by 2. The unit digit is even. Very good. And because it is divisible by 2, it has more than 2 divisors for sure. Therefore, it's composite. What about this number? 1, 1, 7.
Okay, so I still think it's composite.
Composite, it is right. Why?
I really don't do it the way I should. I just do it by 100 is a composite, so I think anything above it should be a composite. I think.
No. In composite numbers, you only need to to decide if a number is composite or prime, you need to say the divisors. So is it divisible by 3? I told you yes. I told you how we can check if it is divisible by 3. And then
If the sum is divisible by 3.
it is divisible by 3. It is divisible by 9. Therefore, it has more divisors. It has more than 2 divisors. Therefore, it is composite. We don't care about how many divisors does it have, but because we know that it has more divisors other than the 1 and itself, it's a composite number. That is enough for us.